Hello everyone. Before we get started on today's mini little lesson, we are going to review a little bit with what Mr. Kate went over yesterday, and it was dealing with lesson 3 when you are dealing with numbers in exponential form raised to a power. So remember, whenever we raise a power to a power, it's like you're distributing this power into everything inside the parentheses. And when you distribute, remember we multiply. So this would become x to the 10th because 5 times 2 is 10, and y to the 14th because 7 times 2 is 14. If we look down at the next example, make sure you're distributing the 2 into every single term by multiplying. So the first one, we would have negative 3 to the second power. Remember, anytime you have a negative base or a fraction base, you must put parentheses around it. X, 3 times 2 gives you 6, and y, 8 times 2 gives you 16. So now if I'd simplify that, negative 3 to the second power would be negative 3 times negative 3, which is positive 9, x to the 6th, y to the 16th. That is my final answer. Okay, moving right along to the next page. Now this problem involves multiplication and division. Some students are able to do it all in one step. I'm going to show the multi-step process just so it gives you an idea of how to get it. So I'm going to focus on just what is in my numerator. So if I would multiply that, multiply your coefficients. 6 times negative 8 is negative 48. B, and remember, since we're multiplying with the same base, I add my exponents. 5 plus 6 gives me 11. Then I'm going to rewrite what is in my denominator. So I already did step 1, which was multiply. Now the only thing left I have to do is divide. So negative 48 divided by negative 12 is a positive 4. Remember, my base is B, and when we're dividing with the same base, we subtract our exponents. 11 minus 7 is 4. So 4b to the 4th is your final answer. Let's try another one like that. So here, same thing. We are going to multiply first. So 3 times negative 6, because we multiply our coefficients, gives you negative 18. K, remember, I'm going to add my exponents since I'm multiplying. 3 plus 5 gives you 8. There's no other m in my numerator, so I'm just going to rewrite it. And I will also rewrite what is in my denominator. Now we can follow the rules for division. Negative 18 divided by 2 is negative 9. K is a base, so we're going to subtract our exponents. 8 minus 2 gives you 6. There's nothing we can do with the m, so we're just going to leave it be. So negative 9 k to the 6th m is your final answer. If you're stuck on how I'm doing any of those, make sure you ask your teacher. And we now are going to move right on in our packet. So what I'd like you to do is turn your page to where it says Lesson 4, Numbers Raised to the 0 Power. If you started your homework assignment, there was a question similar to this in your homework assignment, so I'll explain. Right here before we get started are the rules we talked about so far. Remember, when you're multiplying by the same base, you add your exponents. When you are raising a power to a power, you are going to multiply, which are these specific cases, and remember, when you do that, you have to distribute into every single term. Another rule we talked about was the rule for division. So if I have x to the m over x to the n, remember, when we're dividing, we're really just subtracting our exponents. And that's what we've done so far. So this is what your quiz will be on, in addition to negative exponents. But briefly, we're going to talk about exponents to the 0 power. So if you move on to where it says problem set in the packet, which is on page S16, student page 16, we're going to take a look at these. So there are different ways to think about this. one way is just to follow our rules. So, for the first one, number 1, y to the 12th divided by y to the 12th. Well, since we're dividing, you can think of it as subtracting your exponents. So I would have y to the 12th minus 12. Well, 12 minus 12 is 0. Anything to the 0 power, always, 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 is going to give you a final answer of 1. Another way to think of it is this. There's a y to the 12th in the numerator, a y to the 12th in the denominator. They cancel out, and when you cancel out, when you divide by the same value, you'll just get 1. Number 2. Remember, whenever we're multiplying, you could think of this fraction as over 1, so I'm just going to multiply straight across. So 9 to the 15th times 1 is just 9 to the 15th in my numerator. I also have 9 to the 15th in my denominator. So if I continue this, since I'm dividing, I would subtract my exponents. 15 minus 15 gives you 0. So 9 to the 0 power, like I said, anything to the 0 power will always give you 1. The next one, number 3, it's raising a power to the 0 power. So the first thing you're going to want to do is distribute the 0 into every single term inside the parentheses. So I would have 7 to the 0 power times 123,456.789, and then 4 times 0 is just 0 as well. So now, 7 to the 0 power, like I said, anything to the 0 power is 1. Over here, we also have a value raised to the 0 power, which will also give you 1. And if I multiply 1 times 1, my final answer will be 1. For number 4, they're showing you how this right here becomes the other side. So the first thing I would do is multiply everything that's in my numerator. So I would have 2 to the 2nd times 1, which gives you the 2 to the 2nd right here. 2 to the 5th times 1 gives you 2 to the 5th. And now that we have this, we could follow the rules different ways. One way would be to divide. So I have 2 to the 2 minus 2 power times 2 to the 5 minus 5 power. Remember, 2 minus 2 is 0, so I would have 2 to the 0 times 5 minus 5 is 0, 2 to the 0. Like I said, anything to the 0 power is 1, so this is like 1 times 1 with a final answer of 1. And if we look at number 5, what we can do, as always, is group our like terms together, or excuse me, our like bases together. So I have an x to the 41 in my numerator. I have another 41 in my denominator, so I'm just going to subtract them. And I'm going to multiply this by y to the 15 minus 15. So 41 minus 41 would give you x to the 0 times y to the 0. Remember, anything to the 0 power is 1, so 1 times 1 would just give you 1. Whoops. So the big picture I want you to understand from all of this. Any base raised to the 0 power is 1. That's the big picture you need to get from this mini little lesson. Any base raised to the 0 power is 1. So if you still have a question, please let one of your teachers know. If not, you can go onto the Schoology quiz, and good luck.